Hello everyone, my name is Tianyi Chen. Today I will give my final presentation. The topic is the power system of China. We have background, concept development stage, engineering development stage, post-development stage, and challenges. Over the past 100 years, China has experienced a lot of huge challenges. With the challenges in technology and policies, the power system has also developed fast and rapid. Therefore, we will divide the development process into three parts to introduce the background of the power system in China. The first stage is the early stage of development of power system, which is between 1882 and 1937. From the first 12 generator set was built in Shanghai to the close beginning of World War II against Japan. On July 26, 1882, the power plant started to generate electric power and supply electricity officially. In 1903, the frequency of the generator is set to 50 Hz and the voltage is set to 220 V. More and more generators and power plants were built in China. The second stage is from 1937 to 1949. During the anti-Japanese war from 1937 to 1945, power plants in coastal provinces such as Jiangsu and Zhejiang have been destroyed or demolished to the real area. The power industry in southwest China has developed steadily due to the need for war. Based on northeast China, Japanese imperialism produced and raised military supplies for the war, which led to a certain development of the northeast China power system. Until the victory of the anti-Japanese war in August 1945, the total national installed capacity reached 2.9 million kilowatts. The Liberation War in China had a large influence in the power industry during 1946 to 1949. By the end of 1949, the total power generation capacity was decreased to 1.85 million kilowatts. The third stage is from the establishment of the People's Republic of China to now. It can be divided into four steps. The first step is the recovery and the first 5-year plan from 1949 to 1945. During this period, the electric equipment developed rapidly. The generator production was 20.9 thousand kilowatts. Motor production was 630,000 kilowatts, and the transformer production was 1,167 kVA. The second step is Great Leap Forward and adjustment from 1957 to 1966. The power industry developed very fast, while the goal was set too high to reach. The electricity production reached 2.2 million kilowatts in 1960, which was close to Britain, Japan, and France. The third step was the Cultural Revolution from 1966 to 1976. The electricity output was deeply influenced by politics and decreased to a low amount that could not satisfy the demand. The fourth step is Chinese economic reform since 1978 to now. The electric industry grows rapidly and steadily. By the end of 2018, China's total social power consumption is 684.9 billion kilowatt hours, and total power generation capacity is 699.4 billion kilowatt hours. In my opinion, the power system of China is very complex. It can be divided into four subsystems: generator system, transformer system, transmission system, and distribution system. Then I will do an introduction to those four subsystems. First of all, it is generator system. As is known, generators convert primary energy into electrical energy, and there are many different ways to provide electricity. The hierarchy of the system can be divided into three main classes, which are thermal generator, hydro generator, and nuclear generator. Thermal generator uses combustibles as fuel to produce electricity, coal for example, When the fuel burns, it heats the water to generate steam and converts the chemical energy of the fuel into heat. The steam pressure pushes the steam turbine to rotate, and heat is converted into mechanical energy. And then the steam turbine drives the generator to rotate to convert the mechanical energy into electrical energy. The hydro generator uses kinetic energy and potential energy of water to produce electricity. Water is drawn from the height of the river, and the pressure or velocity of the water is used to impulsively rotate the turbine to convert the gravitational potential energy and the kinetic energy into mechanical energy. Then the turbine drives the generator to rotate and convert the mechanical energy into electrical energy. The nuclear generator uses heavy nuclear fission to produce electricity. As a subsystem, the generator can be divided into four components: stator, rotor, cover, and bearing. The main function of the stator is to generate a rotating magnetic field and convert this field to an electric current. The rotor is cut by magnetic lines of force in a rotating magnetic field to generate current. The cover is used for fixing and supporting the stator. Bearing is for withstanding the mechanical imbalance force from the rotor and mechanical pull force from rotor eccentricity. Secondly, we will discuss the transformer system. The hierarchy of the transformer can be defined into three classes. There are voltage transformer, current transformer, rectifier transformer, and inverter transformer. The voltage transformer can increase the voltage or decrease the voltage from one side to another. The voltage is increased for transmission and decreased for the use by the residents. The current transformer is used to increase or decrease the current. Most of the current transformer is used for decreasing the current for the benefit of measuring current directly by the meter. Rectifier transformer can transfer the AC to DC. Most industrial rectifier DC power supplies are obtained from the AC grid through rectifier transformer. Inverter transformer is used to transfer the DC to AC. Inverter transformer is widely used in computer, television, air conditioning, and so on. As a subsystem, the transformer can be divided into three components, which are primary coil, secondary coil, and transformer coil. The primary coil is the input of the transformer. It is usually connected to the power supply. The primary coil gets the energy from the power source and transmits energy to the secondary coil in the electromagnetic induction manner. The secondary coil is the output of the transformer. When the secondary coil is induced by the primary coil electromagnetically, the voltage will be generated in the secondary coil. The level of the secondary voltage is determined by the number of turns of the secondary coil. The more turns of the secondary coil, the higher the secondary voltage is. The transformer coil is the main magnetic circuit part of the transformer. It usually has a high content of silicon. The transformer coil and the coil form a complete electromagnetic induction system. The capacity of power transmission in the power transformer depends on the material and cross-section area of the transformer coil. The third subsystem is the transmission. When it comes to the transmission part, we always connect it with the transmission line. The hierarchy of transmission can be divided into AC power transmission and DC power transmission. AC power transmission is a method of delivering electricity in an alternating form. The levels of AC power transmission in China are 35 kV, 110 kV, 220 kV, 500 kV. DC power transmission is a method of delivering electricity in an unchanged form. The alternating current generated by the power plant is converted to a direct current by a rectifier and the DC is transmitted to the power receiving end. Then the inverter converts the direct current into an alternating current. This method is mainly used in the networking of long-distance high-power transmission and non-synchronous communication systems. It has advantages of less line investment, no system stability problem, faster regulation, and reliable operation. The levels of AC power transmission in China are 500 kV, 800 kV, and 1000 kV. As a subsystem, the transmission line can be divided into four components, and they are transmission wire, line tower, insulator, and a lightning protective wire. Electricity is transmitted through the transmission wire. The wire is usually made of strand aluminum wire. For the increment power quality, the wires are usually bundled. The role of the line tower is to support the transmission wire and prevent the wire from contact with other conductors to create a line ground fault. So the line tower should be tall and stable. The line tower can be divided into wood structure, steel structure, aluminum alloy structure, and reinforced concrete structure. Wood structure tower has the disadvantages of low strength, short life, inconvenient maintenance, and is restricted by timber resources control. Therefore, wood tower has been limited in China. The steel structure is the main structure in high voltage transmission. The aluminum alloy structure tower is too expensive, so it is only used in mountain areas. Reinforced concrete structure is most popular in China because it has advantages of short production cycle, long service life, and simple maintenance. The main function of the insulator is for electrical insulation and mechanical fixation. It avoids breakdown or flashover along the surface under the specified operating voltage, lighting over voltage, or internal over voltage, and avoids damage under the specified long-term and short-term mechanical load. Lightning protection wire is installed to protect the equipment from lightning strikes. During the thunderstorm season, the lightning from the sky goes into the lightning protection wire through the lightning rod and goes into the ground finally. The last subsystem is the distribution system. It is directly connected to the user in the power system and distributes power to every electricity user. As a subsystem, it has four components, which are distribution substation, distribution circuit, distribution transformer, and relay protection. Distribution substation has the function of adjusting voltage, exchanging power, collecting and distributing electrical energy. It plays an important role in ensuring the safety and economic operation of the power grid. The distribution circuit transmits power from a step-down substation to a distribution transformer, or transmits the power from the distribution substation to the electricity consumption unit. A distribution transformer is a device that is used to change the AC voltage to another voltage at the same frequency. Relay protection is an important measurement to detect faults or abnormal conditions, and it can send out alarm signals or directly isolate and remove faults. The power system of China is very complex, and it has experienced a long and tough time during the engineering development stage. The stage can be divided into three parts, which are advanced development, engineering design, and the integration and evaluation of the four subsystems I talked before: generator system, transformer system, transmission system, and distribution system. The first one is the advanced development stage. It is to resolve the majority of uncertainties or risks through analysis and development and to validate the system design approach as a basis for full-scale engineering. In this step, engineers always make requirement analysis ahead. Therefore, engineers have done plenty of research in the power system of China. The first generator set was built in Shanghai, Guangzhou, Nanjing, and other coastal cities of China, where had a power supply in the very beginning. These plans indicated that these cities have a huge need for electricity because there are more industries in large cities around the coastline. And now, Guangdong, Jiangsu, and Shanghai, Shandong provinces are the top 3 electricity consumption provinces in 2018. It meets the requirement of those large cities. The second one is the functional analysis and design. During the process of designing a substation, the engineers analyze the functions of substation. So they divide the substation into the transformer area, bus and outgoing area, protection and measurement area, and the direct current source area. Each area has its function. The transformer area is to realize the transformation of different voltage levels based on the need. For example, 220 kV is transferred into 335 kV for the usage of factories. 110 kV is transformed into 10 kV for the usage of households. Bus and outgoing area can realize the function of pooling and redistributing electric power. It can satisfy the need for real demand for different loads. Protection and measurement area functions as the measurement of the data, like current, voltage, frequency, and so on, to prevent the devices into fault. If the current is too high or the voltage is too low, it shows there is an abnormal or fault. The direct current source area is to provide breaker and protection devices with power supply. The next one is prototype development. During the process of designing, engineers need to make a prototype of the system to evaluate so that they could verify the feasibility of the system and reduce the potential risks. For example, when we design a new transformer, we would make a prototype to test the transformer performance under different circumstances. Prototype is very important because it represents the result from the idea and the real product. With the improvement based on the prototype, more and more perfect products will be put into usage. The last is the development testing. Engineers usually create different test plans and conditions to evaluate critical elements and development. Before a new device is put into usage, engineers will do a series of testing. Insulation resistance testing is an important test. It can effectively detect the overall moisture of the transformer insulation, moisture or dirt on the surface of the component, and the centralization defects of penetration. Impulse withstand voltage test is another important test. This test is used to check the insulation performance and protection performance of various high voltage electrical equipment under the impact of lightning over voltage, operating over voltage, and other shock voltages. The test voltage is much higher than the voltage that the equipment insulation can withstand during normal operation. A lot of high voltage electrical equipment must undergo impact withstand voltage test during the factory test, type test, or after overhaul. The next stage is the engineering design stage. The goal of this stage is test requirements and engineer the prototypes. The task of system engineering is to handle the unknown unknowns during the phase. Three characteristics need to be into considerations: reliability, maintainability, and producibility. Reliability shows the probability of a system that works successfully. If it is used to represent as a function, it can be written as the number of successful operations divided by the total number of operations. In a power system, the reliability of relay protection is one of the four basic requirements that the relay protection device must technically meet. Relay reliability includes safety and reliability, which are the most fundamental requirements for relay protection. For safety, it is required that the relay protection does not act reliably when it is not needed. That is, no malfunction occurs. For reliability, the relay protection is required to operate reliably when a fault occurs within the specified protection range. That is, not to refuse to operate. Missed operation and the refusal of relay protection will bring serious harm to the power system. Even for the same power component, as the development of the power grid, the impact of protection from malfunction and non-repudiation on the power of the system will change. The second characteristic is maintainability. The definition of maintainability is a measure of the ease of accomplishing the functions required to maintain a system in a fully operable condition. There are two parts of maintainability. There are corrective maintenance and preventive maintenance. Corrective maintenance is the meaning of repair if a system fails during operation. Preventive maintenance is to schedule periodic servicing, including testing to detect and deal with potential failures. In corrective maintenance of power relay system, there are two methods, which are observation method and comparison method. The observation method refers to visually observing whether an electrical relay protection device has a fault. In the power system, if the operating load of the power system exceeds the maximum load value of the relay protection equipment, it is likely to cause the fault of the relay protection equipment. For example, the fuse in the relay protection equipment suddenly blows out and the relay protection equipment will have a pungent smell. In this case, maintenance personnel can use observation methods to observe whether the relay protection equipment has a fault. If there is a burnt smell from the electrical relay protection equipment, they can judge the relay protection is good or not. If a malfunction has occurred inside the device, it should be replaced. The comparison method is to compare two devices with the same model and to find out the differences between the two comparisons, which is conducive to determining the specific location of the fault. When repairing electrical relay protection equipment, once it is found that there is a fault in the relay protection equipment, maintenance personnel should use a device with the same model as the equipment for comparison, and it must be assured that the equipment used does not have performance and quality problems, and make the two devices in the same operating state to find out the differences. So the relay protection equipment can be targeted for repair. For countermeasures of power system relay protection system management, the new century is the world of network information. Therefore, advanced information technology has been used in various of life. In order to better ensure the stable operation of the relay protection of power system, it is necessary to widely apply some advanced information technology so that it can better analyze the collected data and let the relay protection device more fault information can be obtained, which further improves the reliability of the relay protection device. Therefore, in the era of information, it is effective protective relay protection devices and information technology. The last one is producibility. The power system is a large system and it needs a lot of devices. Therefore, the manufacturing factories like current transformer factories, breaker factories, isolation switch factories must have producibility. The purpose of production on a large scale is to reduce the cost. Also, since all the products are made under the same requirements, the quality of the product can be guaranteed. There are fixed measurements to make the production easier, which are making full use of commercially available parts, subcomponents, and even components, setting tolerances of mechanical parts well, design of subassemblies, maximum usage for high-rate production, use of easily formed or machined materials, and maximum standardization of subassemblies. In my opinion, the first two measurements are the most important. Thousands of electric device components are put into the power system, so it shows the maximum usage of commercial components. To set dimensional tolerances of mechanical parts well within the normal precision of production machinery. China has a complete power system in the past few decades. When the whole system is finished of design, the last stage is integration and evaluation. This phase is not mandatory if the system is well engineered. However, even though the system is designed perfectly, there would still be some unexpected problems when every element in the system gathers together. When it comes to the power system of China, which consists of many subsystems, it is very necessary. For example, distribution system is a subsystem and it can be divided into distribution substation, distribution circuit, distribution transformer, and relay protection. When the four components are tested one by one, engineers should still test it as a whole system. Engineers usually simulate a fault in order to test the cooperation between each component. If the relay protection does not react correctly when a fault happens in the distribution circuit, it shows a problem. That is why engineers do the integration and evaluation stage. After the engineering development stage, the last stage needs to be mentioned. This stage is based on the stage of concept development and engineering stage. It is called the post-development stage. At this stage, the designing job is almost done. The engineers are asked to build each subsystem together into a finished product. During this progress, the engineers need to learn from the evaluation stage and ensure that each component works perfectly in the large system. When the installation and assembly work is finished, engineers also need to supply with support device service. The two processes that I talked about are so-called production, operation, and support. In the opinion of the production of process development, the purpose of it is that the engineering designs and specifications created during the engineering development stage are reflected in the same set of hardware and software components, and each group is assembled into a system suitable for the user. This stage requires that the entire system can be executed as required. For example, a substation needs a lot of components like circuit breakers, current transformers, insulation switches. In the power system of China, these components are manufactured by different companies, and there are a lot of factories which have these productions. Therefore, the devices in the substation are made in different places in China or even the world. Because some components are very large, like a transformer, these components are usually assembled in the substation. The next part of post-development stage is operation and support. In theory, the tasks of system engineering have been completed before this phase, while in practice, the operation of the modern system is never without incidents, including initial installation, significant tests, and component replacement during the periodic maintenance periods, repairs, and major upgrades of large complex systems. For example, Nanjing Nanrui Company produces relay products. After their products are put into usage in a power system, they still need to give support services for routine maintenance and replacement. During the development of the power system in China, there existed a lot of challenges that the electric power engineers face. Nowadays, there is still a lot of challenges need to be solved. The first challenge is that the engineers need to pay attention to all the components of the power system. Any error of components will lead to a tragedy. For example, in August 1975, in Huaihe River scene of southern Henan province. A dam burst made thousands of people lose their hometown because the number of drainage gates was reduced from the original design of 12 hole to 7. The second challenge is the connection between each subsystem. If one transmission line cannot transmit electricity, it will cause another transmission line overload. For example, at 9 p.m. on July 1st, 2006, two 500 kV lines running in parallel in Huazhong power grid were tripped by mistake, and all the loads were transferred to 220 kV lines, causing multiple generator sets to trip. Now, the power grid is getting bigger and bigger. Once there is a power outage, it will not only cause a huge economic loss, but also leads to social chaos. The third challenge is severe tests for safe and stable operation. Non-traditional hidden dangers brought by the application of new technologies, such as information technology, placing higher requirements on system support capabilities, transfer capabilities, and adjustment capabilities, which has brought severe challenges to the safe and stable operation of power systems. In addition, various natural disasters occur frequently, and the challenge of ensuring the safety of the power system is even more arduous, and the risk of large-scale power outages always exists. The fourth challenge is that the issue of clean energy consumption remains prominent. The mechanism for solving the problem of clean energy consumption is still prominent in the mechanism, such as insufficient coordination of development, insufficient flexibility of the system, leading to peak shaving difficulties, mismatched transmission channel construction, large-scale consumption, redistriction integrated planning of water and electricity domains, weak management, new energy sources with technical constraints, insufficient demand-side potential, incomplete market mechanism, and limited policy measures are still not well resolved. In the future, large-scale new energy power generation will be connected to the grid and consumed. The pressure and the challenges of hydropower development and transmission will become more and more difficult to meet the country's general requirements of advancing the energy production and consumption revolution and building a clean, low-carbon, safe, and efficient energy system. The fifth challenge is the difficulties in the operation of coal power companies and the weak ability to ensure clean development. Coal power generation accounts for 65% of the country's power generation. For a long time, it plays an important fundamental role, such as safe and stable power supply, emergency peak shaving, and centralized heating in the power system. In the next 2 or 3 decades, based on the development, it will still play a fundamental and flexible power supply role, and it will still be the main form of energy that provides power and electricity for the power system. Coal power has long-term operating difficulties and even losses, which is not conducive to the safe and stable supply of electricity, and it has greatly weakened the capacity of clean development of coal power. The challenges of clean development of coal power is even more difficult. The sixth challenge is nuclear power construction stagnates. Nuclear power is a type of clean energy power generation that can replace coal on a large scale and provide stable and reliable power to the power system. It is an important means to achieve the national non-fossil energy development goals of 2020 and 2030 and to build a clean, low-carbon, safe, efficient energy system. However, nuclear power development has stagnated in the past 2 years, and the new nuclear power projects have not been approved for two consecutive years, and the scale of nuclear power investment has also declined for two consecutive years. Thank you.